Grade 8, we're starting chapter 4, which is about percents. And it's not a very long chapter, there are 4 sections. 4.1 for today is representing percents. 4.2 is about fractions, decimals, and percents, being able to do conversions back and forth. 4.3 is calculating the percent of a number. And then 4.4 will be combining percents. After that, we'll do some review, and then it will be time for your unit exam. Once again, some of the key concepts throughout the chapter of things that you need to be able to understand. For 4.1, you need to know that most percents are between 0 and 100, but that it is possible to have percents between 0 and 1, so fractions of a percent, and also percents that are more than 100. So commonly you hear the phrase 110%. Well, 110% is legitimate, you can't have that. And then for the other sections, there's concepts here as well. But today, 4.1, representing percents. Let's take a look. Working example number 1, determine the percent represented on a grid. So, one completely shaded grid, like this one here, is 100%. There are 10 squares by 10 squares on here for a total of 100 squares. So each square is equal to 1%. But we've got a whole grid, which is 100%, but then we've got a second grid that has some more shaded in. So, grid 1, and these are labeled grid 1 and grid 2. Grid 1 has 100 squares shaded. Grid 2 has, and let's see here, this is 4 high, so that would be 40 if it was full all the way across, but there's 5 missing here, so this is 35 shaded ones for grid 2. So in total, 135 squares are shaded. So that means that the diagram shows 135%. This is what we call a combined percent. It's combined because it's 2 grids that are being added together. So a definition for you for combined percent is when individual percents are added together. So for example, 100% plus 25% gives you 125%. That would be combined. Alright, so this shows you an example of something over 100%, but we can have something at the other end of the numerical spectrum where we've got only a partial square shaded. So that one full square would be 1%. A part of a square shaded would be less than 1%. So this little square here is being magnified in this drawing here to show that the square is actually broken down into 10 pieces, and 7 of those 10 are shaded. So this is 7/10 of a percent. So only part of one square of the grid is shaded. This percent then becomes a percent that is between 0% and 1%. If this wasn't shaded at all, it would be 0%. If it was completely shaded, it would be 1%. So because it's sort of between not shaded and shaded, it's between 0 and 1%. And this is called a fractional percent. So there's another definition for you. A fractional percent is a percent that shows part of 1%. So for example, 0.5% would be half of a square shaded. 0.42% would be, well, if you broke one of these squares down into 100 little tiny squares, 42 of those tiny squares would be shaded. 7 3/8%, what that looks like is 7 full squares shaded, and then in the 8th square, 3/8 of it is shaded. 4.5%, you look at the whole number 4, so 4 squares would be shaded, and then half of one as well to cover off the 0.5. So in order to see the fractional percent, you need to zoom in to see the shaded parts of one square. So since one square is 1%, then part of that square is either a fraction or a decimal percent. In fractions and decimals, we can use either of them, and we can find equivalencies so that you actually have both. So the shading here shows 7 out of 10 shaded. Well, 7 over 10 as a decimal, just divide that on your calculator, 7 divided by 10, as a decimal is 0.7. And so in this case it's 0.7 of 1% of the whole diagram, so it's 0.7%. So 7 over 10 is fraction is equal to 0.7 as decimal. Hopefully you remember how to do those conversions from grade 7. So in this case, the diagram shows 7/10 of a percent, or 0.7%. Next up is a show you know. Give it a go.